hers is the fourth string here. So this is the dictionary. But the problem in this is, like if I give an input string, for example, like same, if Asha's is the input string, there is no link for you, so I can just go back to the same state in the automator. I'll build and show. But so next when I go to S, let's say I did the normal try. So I'll go to S, then H and E. But after I come to R, I have to just so this I iterated this part, right, from U till R. But there's this she does not have a R link. So technically I should go back to this her, right? The her is actually a suffix of shell. It's like in this shell, this is a suffix which is also a prefix in the try. So that is the thing that it didn't came to. So technically from this stage, it is synonymous to go to she to her. Okay, from her. Okay, he will. So if you see, what is the word here? This she, right? So what is a suffix in she? He is a suffix in she, and he is also a prefix in this entire try. So if I can build this link from this node 2 to node 1, then on the next input symbol R, I can just iterate from here to here. Because so how do I build this link? So we have to just generalize the failure function for all these things. So how will we? So just for the implementation part, I'll store this whole try as a 2D array than pointer structures. So we can have next of the current state, comma, character. So this is normally try. Like I'm at this state, with this input symbol, it actually go next. If you number all the nodes, and then this will be f of the state. So this is if from the current state, it's a failure. I don't have a character. That's like same thing. I don't have R here. So this will go from this state. I have to go to this state. So this will be the link actually. And then we'll have this the output for each nodes of the K. So output of K will be like you can have a 2D vector for all the places where it will match. Match as in like once you iterate that input word, I have to know. For example, okay, I'll just build the whole automata. So from every node, okay, so let's build this failure function for every node. So for H, what is the failure function is? Consider the full word for every node. Consider the full word ending at that node. Since it's a try, it will be the full prefix. So consider all the proper suffixes of this prefix. And it should be a prefix in the try. So for H, what is the proper suffix? Like this node corresponds to H. This node corresponds to the prefix HE. This node corresponds to HER. This node corresponds to HER. So what is the proper suffix in this H? Nothing, just null, right? So this will have a link failure function. We'll go back to the root node because I don't have a character that goes to any other places than E. So this node corresponds to HE. The proper suffix is E or HE.
No, HE is not.
No, sorry, E. But there is no root, there is no E link, E prefix in the try. So this will also go back to the root node. So in case of failure, I have to start over. And then for R, the proper suffix will be ER or R. There's neither of them. So even this node, if there's a failure at this node, I have to start over. There's no, I do not consider any intermediate matchings. For HER is actually, ER proper suffix S. S is actually a prefix in this try. So we should have a link from here to here. Then for HIS, here again this H I have already done. For this I doesn't have any prefix. For HIS, I have a proper prefix S. For S, there's no proper prefix. You go back to the root. For H, I have a proper prefix. For proper suffix, which is a prefix, so it's H. And HE, I also have see this word is SHE, right? SHE has a proper suffix which is HE, and HE is a prefix. So I should have a link from this node to this node. I'll create it properly. Let me use dashes for these links. These are the failure links. So how do we build this automata in linear time? So what do we do for KMP? If the current node is some x, we checked if the next character is present or not. If it's present, I just forward to the next state. If not, I have to check if the failure state of x, if I add one more character, if it's present in the structure or not. If not, I go 2 steps back, f of x. I just go another failure f of x. In the same way, you can do in here, but you have to do it as a BFS traversal, because we have to maintain invariant. The invariant is for every node in this trial, it will have a prefix, right? We should have solved all the prefixes which are smaller than this. So if we, if it is root node, if you do a BFS traversal, it will maintain the invariant. Like when you reach the current node V, you would have already solved for all the nodes whose length from the root is smaller than V. So that will have the failure function for the smaller cases. It's like DP. For the current node, V, I want a suffix. This is also a prefix. So the V's parent, V's parent would have been already solved because I maintained the invariant in the BFS. So that will have another suffix. For example, let's call, okay, so if I have some XYZ, if Z is the current node, like XYZ is the current node, and I've already solved for XY, the failure function, I'll just check if the failure function for this node plus on addition of this node is actually prefix or not. If not, I then go back to the failure function for X. I've already solved for all these parts if I do a BFS. So to pre-compute this automata, first build a trie. So it will have just an insert function for, so insert of a string, for inserting that particular string into a trie. So after you have built the trie, you have to build the automata. The automata you have to start BFS traversal from the root. And as you go for each node, you have to just do the same jumping, like what is it for KMP.